When Galileo pointed his telescope at Jupiter in 1610, he was the first person to see the giant orbs attached to it by springs. His actual drawings compared night after night show these bright spots moving back and forth past Jupiter, exactly the same as if they were balls hanging off of springs. I mean, yeah, Galileo was looking at the moons of Jupiter, but if you plot their motion back and forth over time, it forms a sine wave, and that motion is mathematically identical to the motion of something bouncing up and down on a spring with a linear restoring force, also sine waves over time. From a side-on perspective that projects 2 dimensions down to 1, things in circular orbits look exactly like they're springing back and forth on giant coils of wire. Now, I'm not saying that we should think of the moons of Jupiter as being held on by giant invisible springs, but it's a valid mathematical model when viewing them from a distance. It'll make the same predictions about the motions of the moons as the orbiting in circles due to invisible gravity model, and one can be mathematically transformed into the other. The moons of Jupiter aren't alone in having multiple mathematical descriptions. Projectiles and storms on Earth experience a force called the Coriolis effect that causes them to turn. But viewed from an external perspective, the projectiles and storms are what goes in a straight line, while the Earth turns beneath them. Both models, if you use them carefully, make correct predictions about reality. And quantum phenomena can be modeled in at least 3 different ways that all give the same predictions. As a particle being guided by a spread-out pilot wave, or as a spread-out probability wave that collapses to a single point, or as a particle exploring all possible paths it could take and interfering with itself along the way. All 3 of these mathematical models suggest different ways of thinking about what's actually going on in quantum systems. And the fact that all 3 of them give the same experimental predictions suggests that perhaps none of them is the right way to picture what's happening. Mathematical models give us nice, easy-to-digest pictures of how the universe works. Moons orbit around planets, atoms bind together into molecules, electrons are clouds of probability, and so on. But we need to be careful how much weight we give to the models in our heads, or on our blackboards or computer screens. Do Jupiter's moons move like they're pulled back and forth by the invisible force of springs? Or held in orbit by the invisible force of gravity? Or are they following helical paths which are actually straight lines in curved space-time? The way we describe the world influences the way we think the world is, even when there are other, equally correct ways of describing the world that paint entirely different pictures from our own. That's not to say we should accept wrong ideas, but we should be aware that sometimes a different correct picture, one we haven't considered, is the one we need to see.